Welcome students to the session of Eulers equation of motion and Bernoullis equation. Today we will see about Eulers equation of motion and from which Bernoullis equation is derived. So before going into Eulers equation of motion, we should know the governing principle. Here the governing principle is based on the conservation of momentum or the Newton's second law of motion. So let us now recall what is meant by Newton's second law of motion. In case of Newton's second law of motion, we should know about a property called as momentum. The momentum is given by mass into velocity, where P is nothing but momentum, is nothing but the product of mass and velocity. I generally used to crack a joke. So if I used to have a running race with my students, surely they will win. If I am going for a 100-meter running race, if I am here, it's me, and my student is here. So both are going to have a 100-meter running race, a sprint race. Definitely I will be lagging and the student will be reaching the target earlier. This is because the speed of the student along with me is more than the speed of mine. But I used to tell in another way, compared to the velocity and speed you have one, but compared to momentum, I have one. What is momentum is nothing but the product of mass and velocity. So when the velocity, even though his velocity is more, his mass is less. I am a little bit bulky and hence my mass is more compared to him. So my mass into velocity will be higher than what? His momentum. So with respect to speed, he has won the race. With respect to momentum, I have won the race. Like that I used to crack the joke in the class. The idea behind this joke is that you should know that momentum is nothing but the product of mass and velocity. The product of what? Mass and velocity. That is the idea what we want to communicate. Now what they are telling means this rate of change of momentum. I also used to tell the students rate means always it is d by dt. Gradient means it's always d by dx. Anything divided by distance is nothing but gradient. Then flux means anything divided by area is called as flux. So in this aspect, we are going to see what is meant by the rate. Rate means the change with respect to time. So the Newton's second law of motion says that the rate of change of momentum, which means dp by dt, is directly proportional to the force applied. So this is only the theorem says by Newton's second law of motion. The Newton's second law of motion says that the rate of change of momentum, that is dp by dt, is directly proportional to the force applied. So if I am going to put instead of p as mass and velocity by dt, then F will here mass cannot be, mass is constant and hence it can be taken outside the differential operator. So it will become m into dv by dt. So if I am going to remove the proportionality constant, the constant can also be added to this mass. So once again it's going to be constant only. So m, what is this dv by dt? The rate of change of velocity is nothing but what? Acceleration. So students used to tell the second law of motion as what? Force equal to mass into acceleration, or the product of mass and acceleration is nothing but the force. Okay. So if you are going to apply more force, there will be more change in the momentum. For example, if I have this marker, if I am going to apply less force, then the momentum change will be less. If I am going to apply more force, the momentum change will be more. Very simple concept. Okay. Then one more thing is that the rate of change of momentum also takes place in the direction of force. If my force applied is in this direction, the rate of change of momentum will also be in this direction. If I am going to throw like this, or the force is going to apply in the opposite direction, the momentum change also will be in the opposite direction. So to conclude, everybody knows that From Newton's second law of motion, we know that F equal to m into A, where the force will be equal to mass and acceleration. So this have been added from the concept called as momentum. Concept called as what? Momentum. Now, when considering the force equal to what? Mass into acceleration. This force can be broadly classified as surface force and body force. So you may wonder what is meant by surface force, what is meant by body force. Generally, the pressure force is considered as surface force because pressure will always act per unit area. So it can't act on the entire body. It can act on a unit area. Frictional force, even though the entire thing is there, but if I go and stand means it is because of the friction between my legs and the floor. So there is nothing but what? Frictional force is also an example of what? Your surface force. Then you may think, what about the body force? The body force is a force which should act on the entire body. For example, if I am going to dive from third floor to the ground floor, now the force which is acting is nothing but called as gravity force. This force will not act on the surface. This force will act on my entire body, and hence gravity force is an example of body force, which will act on the entire body. Whereas pressure force is a force which acts only on the particular surface. As well as frictional force. Then also we can have the another example for the body force. I can classify like this. The another force for body force is nothing but magnetic force. We can't tell the magnetic force is acting only on the surface. It will be pulling the other magnet or the iron towards itself, the entire mass. So it is nothing but called as what? Body force. So magnetic force is an example of body force. Can you tell me one more example of a body force? Can you think a little more? Yes, it is electrical force. If I am going to have some shock, whether the shock or the force which is exerted by the electricity will act on my surface only? No, it will act on my entire body. So the electrical force is also an example for body force. So now we can classify the forces as surface force and body force. There are certain examples for surface force and there are certain examples for the body force. Okay, the surface force example of pressure force, frictional force, etc. And coming to the body force, they can be classified as a gravitational, magnetic and electric, etc. I have given some examples, but still there are many to cover. In deriving the Eulers equation of motion, we have considered only one surface force and one body force. What is one surface force is nothing but the pressure force, and only one body force is nothing but what? Your gravity force. So here, when I am going to consider the force, this force I am going to take only one component from surface side and one component from the body force side. From the surface force side, it is called as what? My pressure force. From the body force side, I am going to take what? Gravity force. And I am going to derive the expression. While I am deriving the expression for Eulers equation of motion, we are having the following assumption. The assumptions are, if you want to list down the assumptions involved in deriving the Eulers equation of motion, are nothing but the flow is inviscid. What is it inviscid? There is no viscosity possessed by the fluid, which is considered to be an ideal fluid. It's not a real fluid. But we are going to assume the flow doesn't have, or the fluid doesn't have any viscosity or viscous nature, and hence the flow is inviscid. The second thing is the fluid is incompressible. So here incompressible means, already we have discussed a lot. Incompressible means the density remains constant. It will not vary. The third assumption is that the flow is steady. It's a steady flow. What is my steady flow? The parameters like velocity will not vary with respect to time. So dou v by dou t will be equal to 0. So the parameters like velocity and all, they have reached already a steady state. There is no fluctuation or variation with respect to time. It's not called as what? Steady state. So here we have made three assumptions while deriving the Eulers equation of motion or Bernoullis equation, the assumptions are the flow is inviscid or the fluid is inviscid. The fluid doesn't have any viscosity property. So we are assuming like that, but the real fluid will have the viscosity, but we are assuming there is no viscous nature. So it is called as inviscid. The second condition is that it is what? Incompressible. That is, the density remains constant. And the third assumption is that the flow is steady. It will not vary with respect to time. Now with that assumption, now let us move on to the actual derivation of this Eulers equation. Now I will consider a fluid element. Now I am considering a cylindrical fluid element like this, and the flow is going to happen in this direction, and let the length of this fluid element be ds. The cross-sectional area at 1 is nothing but dA. The pressure force with which the fluid is moving is P. Okay, the length of this fluid element is ds. On this, the center, through this line, the particle is moving, and let us say this is the streamline. I hope everybody know what is a streamline. The tangent to the streamline gives the velocity of the fluid at that instant. So if I am going to make a tangent at this particular point in the flow, in the streamline, that the tangent will give me the velocity of the fluid particle at the time, at that point. Okay, that is something to call as what? My streamline. Okay, streamline defines the, or the tangent to the streamline defines the velocity of the flow at that particular instant. Okay, that is something to what? Streamline. So the fluid enters here, and the fluid tries to move away like this, and it tries to go like this. And when the fluid is moving, its weight will be acting entirely downwards. So this is nothing but what? Weight. So let us say this is theta. It's making an angle of theta with the vertical. Okay, this streamline is making an angle of theta degree with the vertical. I will repeat once again. I am going to consider a fluid motion which is going to enter at 1. I am going to leave through this fluid element of length ds and area dA, and the streamline is going to travel like some path. It's having its own path and is traveling along its own path. Now I want to write down the corresponding energy equation or the corresponding this force equation. We know the force is what? Mass into acceleration. We know that what? The fundamental principle is what? Conservation of momentum. So force equal to mass into acceleration. Very good. Before proceeding this one, I want to recall you the usage of Taylor's series. Taylor's series. So what is meant by Taylor's series? Means if I know a value at x, if I want to find the value at x plus delta x, where the distance between the two nodes is delta x, and delta x is going to be very, very small, then I can apply the Taylor series. What is the meaning of Taylor series? F of x plus delta x will be equal to f of x plus dou f by dou x into delta x by 1 factorial plus dou square f by dou x squared into delta x whole squared by 2 factorial plus dou cube f by dou x cube into delta x cube by 3 factorial. I hope everyone know what is 3 factorial. 3 factorial means 1 into 2 into 3. 4 factorial means 1 into 2 into 3 into 4. I hope you know, everyone know this. So what is the use of this Taylor series? Means if I know the value of a function at x, then I may be in a position to find the value of the function at x plus delta x. I will repeat the statement. What is the usage of the Taylor series? The usage of the Taylor series is that if I know the value of the function at x, so if you know f of x, then you can find the value of the function at x plus delta x. That x plus delta x is nothing but the new one which you do not know, but we can find with the help of Taylor series. But you can find it with the help of what? Taylor series. Now let it be there. And when the distance becomes very small, it is enough to negligible these terms. Why? Because delta x itself already very, very less. Let us say delta x is 0.02. So what will be delta x squared? Delta x squared will be 0.02 whole squared. So it is 0.02 into 0.02. So it will become what? Still very, very less. 0.004. So that value will become very less. So if delta x square is very less, means delta x cube will be what? Still lesser. So we can neglect the higher order terms. So it's enough to have the first two terms when delta x is very, very small. When delta x is very, very small. So here also we are considering the fluid element of having a very small length of elemental length ds. The ds is similar to what? Your dx or delta x. Here the length of the fluid element is very, very small in nature. Okay. So now we know this formula by using the Taylor series. Now let me try to equate the forces which are acting on this fluid element. Now when the particle is trying to move from 1 to 2, let us have this is 1 and this is nothing but a section say 2, when the fluid is trying to move from 1 to 2. Now the force is nothing but the pressure force at this region. So it is nothing but what is pressure? Pressure is equal to force by area. So pressure force means what? Pressure into area. The force which is exerted by the pressure is nothing but called as what? Pressure force. Okay, I told you we are going to consider only the pressure force and the gravity force. Pressure force is nothing but the surface force and your gravity force is nothing but your body force. Okay, so now the pressure force will be equal to P into dA. Why? Because force equal to pressure into area. Here the area is only dA. So this is the force which is making the fluid to move in this direction. It's trying to get into 1. But I want to know what the force is acting at this point. Let us say this point is B. Now the force which is acting at this entry is nothing but what? P into dA. But there will be also another force which will be acting in the other direction. That is also the pressure force. That force is given by Taylor series. That force is nothing but called as what? Your Taylor series. Now I know, now f of x is similar to what? Your P into dA. Now I want to know f of x plus delta x. What is the value of this one? Because the distance is very small distance dx. Instead of dx or delta x it is ds. Okay. Now the value will be equal to P. Now the value is what? Here is what? P. So f of x is similar to P plus dou P by, instead of dou x, what is the distance? Dou s into ds of dA. Here the variable is only the pressure. So I am repeating once again. Since I know f of x is equal to P, I want to know what is f of x plus delta x. Okay, this is nothing but f of s plus ds will be equal to P similar to your f of x plus dou f by dou x is similar to what? Dou P by dou s into ds. This dA is already there. So this is a force which is acting in the opposite direction. If I am going to take the unit vector, this will be acting in the forward direction. So this will be acting in the opposite direction, which means it will be negative. So both are nothing but pressure force only. This is trying to make the flow accelerate. This will try to make the flow decelerate. So the net pressure force will be equal to summation of this force and this force. So I hope you are able to appreciate the usage of Taylor series. Okay. Now I can tell it is P into dA minus P plus dou P by dou S into ds of dA. That's fine. Now one more force is there. That one more force is what? The weight of this fluid element. Now this weight is similar to my inclined one. But I want to know what is the corresponding component in this direction of the streamline. The direction of the streamline. Now this is the resultant force means, what is the corresponding horizontal component? This component will be Fx. Here, and this component will be what? My Fy. This Fy means this also will be what? My Fy. Both are same. Okay, I hope you got it. So this angle is theta. So if I know F, then cos theta equal to what? Fx by F. So what is the horizontal component of this force? Fx will be equal to F into cos theta. So if I have the resultant force, this W is nothing but what? Weight. Weight is nothing but a force. That force is not a surface force, it's a body force. Now I am trying to resolve this body force into its horizontal component and a vertical component. The horizontal component will be acting like this. The vertical component will be acting like this. I hope you got it. This is nothing but my Fy. This is nothing but what? My Fx. Now do you want Fx or Fy? I want only Fx. Why I want only Fx? What this weight, the corresponding component of the weight, which will act along the, which one? Streamline of this fluid element is nothing but Fx. That Fx also will be acting opposite to what? my P into dA. So that is Fx will be equal to what? F into cos theta. Now first of all we should know what is F. F is nothing but what? Weight. Weight is nothing but what? Because force and weight have the same unit. What is weight? Mass into gravity. What is mass? Mass is nothing but what? Density into volume. So density into volume, what is the volume? dA into ds. This is nothing but the volume. So dA, ds into cos theta. I will repeat once again. I want to know what is the body force which will be acting along the streamline. So this is nothing but Fx. I am not worried about Fy. So Fx is obtained as what? F into cos theta, because I know only F. So F into cos theta. What is F? F is nothing but weight. What is weight? Mass into gravity. What is mass? Density into volume. So density into volume, what is the volume? dA into ds. So rho into dA into ds into cos theta. I hope now you got it. So there are two surface force and one body force. So I will make it a note of this one. So we have completed the left hand side. The left hand side is nothing but a combination of two pressure force, PdA minus P plus dou P by dou S of ds into dA minus rho into dA ds g cos theta. So these two forces are nothing but what? Pressure force. This force is nothing but what? Body force, which is acting along the streamline. So we have completed the left hand side. We have completed the left hand side. So what about the right hand side? The right hand side is mass into acceleration. What is mass? Density into volume. Rho into dA into ds. So density into volume into as, or the acceleration along the streamline. Acceleration along the streamline. Let us continue in the further section how to equate these two and end up at Eulers equation and corresponding Bernoullis equation. In continuation to the session we discussed, we can see the conservation principle is the conservation of momentum based on the Newton's second law of motion, where we arrived at F equal to ma. Now this force is contributed by surface force and another is by the body force. One of the surface force is nothing but the pressure force, what we got, one from the inlet and another the exit section. So this is nothing but the summation of the pressure force, and this is nothing but the body force, and this is equal to mass into acceleration. Mass is nothing but density into volume, so density is there. The volume is nothing but dA into ds. And the corresponding acceleration along the streamline. A is nothing but the acceleration along the streamline, AS. Now let us try to explore more about this term, namely the term AS. Okay, now AS, or before going to AS, what is AS? Acceleration. Acceleration is nothing but what? Rate of change of velocity. So we want to first of all know what is meant by velocity. So the velocity will be a function of space and time. Velocity is a function. If you want, you can put a arrowhead to indicate it is different from the volume. So the velocity is a function of space and time. Before going here, I wish to explain about I hope I can erase this particular diagram. I will come back to this diagram once again. So we can see now if I can write x is a function of y and z. If I am writing x as a function of y and z, then what I can write means, if I want to write dx means, it can be written like this. I have to differentiate partially with respect to y, then I have to differentiate partially with respect to z. So I can write like this: dou x by dou y into dy plus dou x by dou z into dz. So this is the way how we have to write when a variable is dependent on other two variables. So for example, now x is a function of y and z. So if we want to find the derivative of that, dx will be equal to dou x by dou y into dy and dou x plus dou z into dz. I hope you got it. Now similarly, instead of x, I am going to have v. V is a function of, if you want I can put a arrowhead also, is a function of s and t, space and time. So how to express this one? So I can write this: dv will be equal to dou v by dou s into ds plus dou v by dou t into dt. So I hope I am just comparing this one. I will write here rho into dA into ds into as. So I am just writing how I have written for ds dx, I have written for dv also. So dv will be equal to dou v by dou s into ds plus dou v by dou t into dt. Divide all the terms by dt. So it will become dv by dt is equal to dou v by dou s into ds by dt plus dou v by dou t. So what is now dv by dt? dv by dt is nothing but acceleration along the streamline. So a is nothing but what? dv by dt equal to this term. So I hope now we have arrived at as is nothing but dou v by dou t plus what is ds by dt is once again lost t. ds by rate of change of displacement. So it is v bar into dou v bar by dou s. So this is how we have arrived at the value of as now. And one more step what we have to see here is that dou v by dou t is 0. Can anyone tell why dou v by dou t is 0? Yes, you are absolutely right. Because in the assumption we had it is a steady flow. Steady flow means any parameter, especially the velocity, will not vary with respect to time, which means dou v by dou t will be equal to 0. So finally my value of as has been reduced to v into dou v by dou s. Both this v are same only. Both this v are, if you want I can even put this as capital V itself. Okay. Now you substitute for as in this equation. Finally we will end up with the Eulers equation. From there if you are going for one more step, I will go with the Bernoullis equation. So I hope now you got the value of as. Okay, so here, so I can write instead of as as what? V into dou v by dou s. If you want I can put even capital V. There shouldn't be any difference. Okay, fine. Now we can expand this term. Now this form is of what? F is equal to m into a. F is equal to m into a. That's fine. So this Bf indicates the body force. This term indicates the body force. This term indicates the surface force. Surface force is nothing but pressure force. Body force is nothing but your gravity. Okay, fine. Now we will expand it. So PdA minus PdA minus dou P by dou S into ds dA minus rho dA ds g cos theta. You even bring this term to the left hand side, so the positive term will become negative, minus rho into dA ds into v into dou v by dou s is equal to 0. So what will happen? This term and this term get cancelled because one is positive, one is negative. So all terms are have a negative sign equal to 0. So multiply this entire equation by minus 1 or divide this entire equation by minus 1. What will happen? This will also become plus 1, plus 1, plus 1. This will become what? 0. Because every time is minus, we can multiply by minus 1 throughout. So I got the expression like this. Now in this expression, let us try to divide by rho into dA ds. Let us try to divide from the first three terms, rho into dA ds. So what will happen? You see, dou P by dou S into ds dA. You now divide by what? Rho into dA ds. Okay. All the three terms, I am even dividing on the right hand side also. Plus rho into dA ds into g cos theta divided by rho into dA ds. Okay, I am dividing by this particular term. Plus rho into dA ds v into dou v by dou s equal to 0. Divide this term also by what? Rho into dA ds. So I am dividing all terms both in the left hand side as well as the right hand side by rho into dA ds. So what will happen? ds get cancelled, dA get cancelled. Here also these first three terms get cancelled, first three terms and first three terms. So finally the equation becomes like this. So finally, if you want, the equation will become like this. Dou P by rho into dou S plus G into cos theta plus V into, if I want I can put capital V into dou V by dou S equal to 0. Okay, that's fine. Now what is cos theta? I want to recall the diagram what has been drawn earlier. This diagram is a streamline where the vertical height is dz and this length will be what? Your ds. So this making an angle of what? Theta. So this is what we have drawn earlier. We have also shown a fluid element with the cross-sectional area dA and the corresponding length is what? This length is what? ds. I hope you can recall now. Now this ds is along the hypotenuse and this along the vertical side. So what will be cos theta? So cos theta is equal to adjacent by hypotenuse. So it is dz by ds. So instead of cos theta, I can replace as what? dz by ds. Okay, that's fine. So I hope I can erase this one. So I can replace for cos theta as a dz by dz. So it is dou p by rho into dou s plus g into dz by ds plus v into dou v by, I will put capital V, dou v by dou s equal to 0. So we can multiply the entire term by ds. So it will become dou p by rho plus g into dz plus v into dou v is equal to 0. Yes. So we have dou p by rho plus g into dz plus v into dou v equal to 0. So if I want to integrate, then what will happen? So this equation is called as your Eulers equation of motion. This equation is called as what? Eulers equation of motion. Now I will integrate this equation. So it will become what? Dou p by rho plus integral of g into dz plus integral of v into dou v is equal to integral of 0. Okay, integral of 0 is nothing but 0. Or it will become constant. It will become what? Constant. Okay. We will tell now. So it will become what? When I am going to integrate dou p, it will become p. Because dp by rho. Here there is no difference between dou and d because there is only one variable. So even I can write this as dp by rho. Here also I can write as this as dv. Both are same because there is only one variable in each term. There is no difference between pde and ode. Okay. So this dp by rho will become p by rho. This term g can be taken outside because g is constant. When I am going to integrate dz, it will become z plus when I am going to integrate v with respect to dv, it will become what? V squared by 2 equal to constant. Because when I am going to integrate 0, it will become what? Constant. Now I can even divide this entire equation by g. I will get as p by rho g plus z plus v squared by 2g. If you want, you can put a velocity sign also, is equal to constant. Is equal to what? Constant. Now this equation is called as the Bernoullis equation. Now whatever we have obtained is called as what? Bernoullis equation. What is Bernoullis equation says? The pressure energy per unit weight plus potential energy per unit weight. Why I am telling per unit weight means what is the formula for potential energy? It is mgh. Here in this case instead of mgh we are putting as what? mgz. So I am going to divide by mg also. Then what will happen? It will become what? Z only. So now Z can be taught as the potential energy per unit weight. Why? Mass into gravity is nothing but what? Weight. So I can tell this is the potential energy per unit weight. This is the pressure energy per unit weight. And this is the kinetic energy per unit weight. Remains constant. Otherwise the Bernoullis equation says that the total energy along a streamline remains constant. The total energy contributes to the kinetic energy, the potential energy and the pressure energy. And it is also better to refer the pressure energy as flow energy because of the pressure change only the flow will happen. Because of the positive pressure gradient only what will happen? The flow will happen. So we can call the first term either as
pressure energy, or we can call the term as flow energy, FLOW, flow energy. So at any time, the summation of the kinetic energy or the kinetic head per unit weight and the potential energy per unit weight and the pressure energy or the flow energy per unit weight remains constant. Otherwise, we can tell along a streamline at any point in the streamline, we can conclude like this: P1 by rho g plus V1 squared by 2g plus Z1. If you want, you can put as velocity sign also. It will be equal to what? P2 by rho g plus V2 squared by 2g plus Z2. So either we can express the Bernoullis equation like this, that is the summation of the kinetic head per unit weight, the potential head per unit weight, and the pressure energy or the flow energy per unit weight remains constant, or like this between two points along the streamline for an incompressible fluid, for an inviscid fluid will be, for a steady flow will be remain constant. That is the final expression what we arrived for the this equation is nothing but what is what? Bernoullis equation. Bernoullis equation of motion. So you may be wondering whether there be any fluid without any viscosity, whether this is possible, whether ideal fluid is possible. No, it's not possible. It's a real fluid will have definitely what? There will be viscous nature in nature. Then why you have to study Bernoullis equation? If you are going to study Bernoullis equation, then you will try to understand what are the maximum amount of efficiency you can go for your system, because the real system will have definitely losses. Here there is no loss. Here there is no loss. So we will try to feel how much we are closer to the ideal one. How much we are closer to the ideal one. When you are going to design a device or a system, then our approach is to be as much as closer go to the what? The ideal one. Just like we are comparing with God. So whether there is God or not, that is a second question. But if you believe God, then why you want God? Because we want, the humans want or tries to attain the status of the heavenly nature or the godly nature. So like that, for any real fluid or a system, we will try to approach to the Bernoullis form, because the Bernoullis form doesn't have any loss as of its own. But for a real condition, there will be some losses. We will try to have or develop a system where the losses are very minimal. In the next session, we will try to derive the Bernoullis equation for various applications, including venturimeter, RFS meter, and other applications. We will be able to enjoy or appreciate the use of Bernoullis equation in the coming future classes. I hope you enjoyed it. Thank you.